If an alien from a distant galaxy visited our planet, they would likely be baffled and amazed by the enormous diversity of life encountered here. There are more than 300,000 species of beetles alone. In fact, out of every 10 animals on this planet, 7 are insects. Sociobiologist Edward Wilson popularized the term biodiversity to describe this heterogeneity, which ranges from macromolecules within cells to entire biomes. This visual abundance creates the impression of an infinite, unbreakable resource, though that perception masks a deep vulnerability. We have recorded slightly more than 1.5 million species so far. However, most experts, including biologist Robert May, estimate the global species diversity is actually closer to 7 million. India occupies only 2.4% of the world's land area, yet it accounts for over 8% of global species diversity. This density suggests that hundreds of thousands of local plants and animals remain undiscovered. We are losing species at an alarming pace, with many facing extinction before they can even be named. Nature's biological library is actively burning, even before we have cataloged the titles of the books stocked there. Distribution of life across the globe follows a strict latitudinal gradient, with species richness aggressively increasing as we move towards the equator. Greenland, at 71 degrees north, has only 56 bird species, while tropical Colombia has nearly 1,400. Tropical latitudes have remained relatively undisturbed for millions of years, providing an immense evolutionary window for diversification. This graph shows Alexander von Humboldt's species-area relationship. He observed that within a region, species richness increases alongside the explored area. This relationship follows a rectangular hyperbola, but on a logarithmic scale, it becomes a predictable straight line, described by a constant regression coefficient. The biosphere operates as a highly structured, mathematically predictable architectural system. Does the functioning of an ecosystem actually depend on maintaining thousands of different species? These plots represent David Tillman's long-term ecosystem experiments. He found that plots with more species showed significantly less year-to-year variation in total biomass. Tillman showed that increased diversity contributed to higher productivity and greater resistance to environmental perturbations like drought. Rich biodiversity serves as the physical load-bearing mechanism essential for ecosystem health and resilience. Stanford ecologist Paul Ehrlich used the rivet popper hypothesis to explain why individual species loss matters so much. Imagine the entire ecosystem as a massive airplane in flight, and every single species as a vital rivet holding its parts together. If every passenger starts popping a rivet to take home, the plane might continue to fly safely for a while. However, the systemic, continuous removal of rivets will eventually cause the airplane to become dangerously weak, leading to a total structural failure of the biosphere. Earth has experienced 5 episodes of mass extinction over the last 3 billion years, long before human involvement. We are currently witnessing a 6th extinction, a process driven entirely by human activities. The IUCN Red List documents the recent loss of 784 species, including the dodo and the thylacine. Current extinction rates are estimated to be 100 to 1,000 times faster than pre-human historical baselines. Human activity is artificially accelerating the timeline of biological collapse. Habitat loss and fragmentation is the most important cause driving plants and animals to extinction. The Amazon rainforest, often called the lungs of the planet, once covered 14% of Earth's land surface. Today, it covers just 6%. Wiping out these dense ecosystems removes the key species that drive major global climate and life support functions. Clear-cutting the tropics is the equivalent of tearing the rivets out of the airplane's wings, and humanity is trapped inside that plane.